Hello, good morning. Today I will discuss the assignment about light waves that I've given you yesterday. Um, we will start from number one. Number one, light of wavelength 70 nanometers is incident on a pair of slits forming fringes 3 millimeters apart on a screen. That 3 millimeter will be delta y, 3 millimeters. What is the fringe spacing? Fringe spacing delta y. So we will find delta y2. When light of wavelength 350 nanometers is used, so this is lambda 1. Given lambda 2 is 350 nanometers, and this is delta y1. And the slit separation is double. So we assume that the slit separation was d1. Now d2 is equal to twice d1. And for this, we will use the equation of delta y equals lambda L over d. So we can see that delta y is proportional to lambda and inversely proportional to d. Yeah. In this case, L is constant. So we can use the ratio between delta y1 over delta y2 will be equal to lambda 1 over d1 divided by lambda 2 over d2 or multiplied by d2 over lambda 2. This is 3 millimeters. Delta y2 is what we're going to calculate. Lambda 1 is 70 nanometers. d1, just let it be d1. d2 is twice d1. And lambda 2 is 350 nanometers. So I can cross them out like that. So I can calculate that delta y2 is equal to 5 multiplied by 3, 15 divided by 2 is 7.5 millimeters. The answer is not one of the options, so I would rather answer A. Yeah. Number 2, monochromatic light illuminates two narrow parallel slits. So this is Young's experiment. The interference pattern which results is observed on a screen some distance beyond the slits, which change increases the separation between the dark lines of the interference pattern. The separation between the dark lines is delta y, and we know that delta y is equal to lambda L over d. So when we want to increase delta y, the first option, we will decrease the distance between the screen and the slit. That will be L. When we decrease L, delta y will decrease. So that is not the answer. Increasing the distance between the slits, is this d. When we increase this, then delta y will decrease. So that is not the answer. Using monochromatic light of higher frequency. Frequency related to lambda is related to lambda. Lambda is equal to V over F. So when frequency higher, then lambda will be lower. Yeah, so when we increase frequency, then lambda will decrease, and lambda is proportional to delta y. Yeah, so when we increase the frequency, then delta y will decrease. So that is not the answer also. The correct answer is D. We use monochromatic light of longer wavelength because when we increase this, delta y will increase because they are proportional to each other. Number 3, a narrow beam of monochromatic light is incident normally perpendicular on a diffraction grating. Third order diffracted beams are formed, so n equals 3, are formed at an angle of 45 degrees to the original direction. What is the highest order of diffracted beam produced by this grating? The highest order of diffracted beam will be produced when theta is equal to 90 degrees. So in this case, we are making a comparison between d1 times the sine of theta 1 equals n1 lambda, and d2 sine of theta 2 equals n2 to lambda. We will make a comparison, and D is the same because we are using the same grating. We can cross them out. And lambda is also the same because we are using the same monochromatic light with the same lambda. So the sine of 45 degrees divided by the sine of 90 degrees should be equal to 3 over n2. And I have calculated that n2 is about 4 point something. Yeah, so the answer, the highest order of diffracted beam produced by this grating is fourth order. Number 4, a double slit interference experiment is set up as shown. Fringes are formed on the screen. The distance between successive bright fringes is found to be 4 millimeters. So that is delta y1, 4 millimeters. 2 changes are then made to the experimental arrangement. The double slit is replaced by another double slit which has half the spacing. So D2 is equal to half D1. The screen is moved so that its distance from the double slit is twice as great. So L2 is equal to twice L1. What is now the distance between successive bright fringes? We will find delta y2. The same as before, we use delta y equals lambda L over D. Yeah, so we only compare L and D because lambda stays the same. We are using the same monochromatic light. So delta y1 over delta y2 is equal to L1 over D1 multiplied by D2 over L2. This is L1 over D1 multiplied by a half D1 over twice L1. Delta y1 is 4 over delta y2. I can cross them out. So I have here 1 over 4. Yeah, so delta y2 will be 4 multiplied by 4 equals 16 millimeters. Number 5, the interference patterns from a diffraction grating. Diffraction grating, let's call this G, and a double slit. Let's call this S, are compared. Using the diffraction grating, yellow light of the first order, n equals 1, is seen at theta 30 degrees to the normal to the grating. The same light produces interference fringes on a screen 1 meter from the double slit. That will be L, 1 meter. The slit separation is 500 times greater than the line spacing of the grating. The slit separation of the double slit is, I call this ds. It is equal to 500 times dg, d of the grating. We want to find the fringe separation on the screen. So we want to find delta y, which will be equal to lambda L over D. L has been given, and later we can find D. Now, first we have to find this lambda, yeah? So, use D times the sine of theta equals n lambda for the diffraction grating. So, here, this is D of the grating times the sine of 30 degrees is equal to a half. That should be equal to 1 times lambda. So lambda here is equal to dg over 2. And now we move on to this one. The delta y will be equal to dg over 2 multiplied by L, which is 1 meter, divided by, this is ds. And ds is 500 times dg. So here I can cross dg out. Then delta y is 1 over 1,000 meters. So that will be 1 times 10 to the minus 3 meters. For number 6, the diagrams show the arrangement of apparatus for a young slit experiment and also part of the pattern formed on the screen with a ruler placed next to it. We want to find the wavelength of the light. In the diagram, we can see that d, the distance between the two slits, is 0.9 millimeters, and L, the distance from the slit to the screen, is 5 meters. And then from the second diagram, we can see from this dark fringe to the last dark fringe, that will be 6 lambda L over D, 6 lambda L over D, 6 delta Y. It is equal to, I calculated that it is 18 millimeters. L is given, D is given, then we can find lambda from this equation. Yeah, you can calculate there from the first given dark fringe to the last dark fringe. 1, 2, 3, 4, 5, 6. So 6 dark fringes is 6 delta Y is equal to 18 millimeters. Yeah, so 6 multiplied by lambda multiplied by 5 over 0.9 times 10 to the minus 3 equals 18 times 10 to the minus 3. And you can calculate lambda to be equal to 5.4 times 10 to the minus 7 meter. That's number 6. Number 7, light of wavelength lambda 600 nanometers is used to illuminate a single slit D 25 micrometers wide. If a screen is placed 1.5 meters from the slit, so L is 1.5 meters, what will be the distance from the middle of the central maximum to the second minimum on either side? So we are speaking about the dark fringes. For the dark fringes, the equation is dy over L equals n lambda. D has been given, L is also given. This n is equal to 2 because we want to find the distance from the second minimum to the central bright fringe. So I guess we have 25 times 10 to the minus of 6 to the minus 6 equal multiplied by y divided by L 1.5 equals 2 times 600 times 10 to the minus 9. So you can find y, which will be 0.072 meters, or it is equal to 7.2 centimeters. Number 8, a diffraction grating is used to measure the wavelength of monochromatic light. The spacing of the slits in the grating, spacing of the slits is D, 1.15 times 10 to the minus 6 meters. The angle between the first order diffraction maxima is 60 degrees. So theta is 60 divided by 2. Because it is shown in the diagram that 60 degrees is the angle between the first order diffraction maxima. So the angle from the first maximum to the central bright fringe will be 30 degrees. And then we want to find lambda. Use d times the sine of theta equals n lambda. N is equal to 1 here because the angle between the first order. Yeah. So d 1.15 times 10 to the minus 6 multiplied by the sine of 30 degrees, a half, is equal to 1 times lambda. And you can calculate that lambda is 575 in nanometers. Number 9. Unpolarized light passes through 3 polarizing filters. This is the first filter, this is I0, and we have a half I naught here. And then the angle between the first and the second filters is 45 degrees. So there will be I1 here. Sorry, this is I1, yeah. I1 is a half I naught. This will be I2. And then there is the third filter. The third filter is forming an angle of 45 degrees to the second filter. What is the relationship between the intensity of light emerging from the third filter, I3, and the incident intensity I naught? First, I want to find I2. I2 is I1 times the cosine squared of theta. And this will be a half I naught times the cosine of 45 degrees squared. So I have a half I naught times a half times the square root of 2 times a half times the square root of 2. This will be 1/4 I naught. And then I3 is equal to I2 times the cosine of squared theta. And this will be 1/4 I naught times the cosine of 45 degrees squared. A half times the square root of 2, a half times the square root of 2. So I have 1/8 I naught. Number 10. When a plane polarized light of amplitude A is passed through a polarizing filter as shown, the amplitude of the light emerging is A times the cosine of theta. Yeah, so initially the amplitude is A, the intensity is I, and then when it is emerging, the amplitude becomes A times the cosine of theta, and we want to find I2, the intensity of light now. What is the intensity of the emerging light when theta is equal to 60 degrees? We know the relation between I and amplitude. I is proportional to amplitude squared. Yeah, so I would like to make a ratio here between I and I2. I is equal to A squared. I2 is A squared times the cosine of theta squared. So I can cross them out. So I get I2, which will be I times the cosine of 60 degrees squared. The cosine of 60 degrees is a half. A half squared is 1/4. So I2 is 0.25 I. That's it. I hope you understand what I was explaining, and if you have any question, you can always ask. Thank you for your attention.